we were discussing about
So
the electron affinity
yes,
of
sir.
elements in periodic table, right?
Yes, sir.
So I given you some homework.
Yes, sir. I wrote.
So have you written the answers for those questions?
Yes. Yes, sir.
So what is the answer? That the electron affinity of chlorine is greater than fluorine. The electron affinity of chlorine is greater than fluorine. What is the reason?
Sir, the question I wrote was why fluorine is more electronegative than chlorine.
Yes.
Sir, it was because fluorine atom is smaller than that of chlorine atom and there is less shielding from other cell of electrons.
Electron affinity. Electron affinity of chlorine is greater than fluorine. Whereas electronegativity electronegativity of fluorine greater than fluorine. Size, atomic radius, atomic radius of fluorine is less than chlorine, right?
Yes, sir.
So electron affinity decreases with the increase of size. So atomic radius, if atomic radius low, if the atomic radius for an atom is low, then its electron affinity is high. Okay, but this is an exception. Chlorine has higher size, greater size than fluorine, but its electron affinity is greater than fluorine. It should be less than fluorine, but it is greater than fluorine. Because we can explain this. There is a factor. The reason number one, fluorine is very small atom. Fluorine very small in size. Okay. Number two, fluorine high electron density. High electron density. High electron density. Size is small. That is why the electron density is the number of electrons by the volume of the atom. So fluorine is very small, that is why its volume is very small. So its electron density, that is why its electron density is very high. Number three, fluorine has low electron density. Low electron density. Number four, fluorine has vacant vacant D subcell. Vacant D subcell. Okay.
So fluorine also has uh, vacant D subcell.
Fluorine.
Yes, sir.
How? Fluorine has no vacant D subcell. What is the electronic configuration of fluorine and fluorine? Fluorine, it is 9 1 S2 2 S2 2 P5. Fluorine. Okay.
Yes, sir.
Fluorine 17 1 S2 2 S2 2 P6 3 S2 3 P5 3D 0. That is vacant. But 2D is not possible. 2D.
Yes,
There
yes,
is
sir.
no D subcell in second orbit. For one orbit 1, only one S. For orbit 2, only one S, 2S and 2P. Okay, for orbit 2, only 2S and 2P. For 3, 3S, 3P, 3D. For 4, 4S, 4P, 4D, and 4F. Like this. So, for second orbit or orbit number 2, there is no D subset, right?
Yes, sir. So how, sir, electron affinity depends on subcell?
Okay. Electron affinity means, what is electron affinity? One extra electron is coming in the atom. Hmm? For example, electron affinity fluorine plus electron equal to F minus. Fluorine plus electron is equal to Cl minus. Now
Yes,
this
sir.
extra electron is coming into the atom. So it should have a vacant, if there is a vacancy in the atom, means electron density is low, is if there is vacant place in the atom, then the electron will come easily. There will be less repulsion hmm, between, suppose this is fluorine atom, this is fluorine, and this is fluorine atom. So this is electron and this is electron. So this electron is coming to the atom. Now there will be a repulsion between the electron in the fluorine. There will be a repulsion between the electron of fluorine and this electron. This repulsion is very high. But for fluorine, because the size is bigger, the electron density is low. That is why the repulsion force between this electron and the electron cloud is very low.
Yes, sir.
Right?
Yes, sir.
So, if there is vacant D subcell, then the electron density is low. Because of that, there is vacant subcell, the electron density is very low. And the repulsion between the incoming electron and the existing electron is very low. So the probability of accepting electron by fluorine is greater than fluorine. Clear?
Yes,
Not
sir.
clear?
Yes, sir.
Okay. Now, electronegativity. What is electronegativity? Electronegativity. Actually, I am seeing the mirror image of the sentences. Are you seeing the mirror image or Saurabh?
So no, sir, it is right. Okay.
It is right or wrong? Now, electronegativity. What is electronegativity? The relative tendency of an atom to attract the bonded electron pair, bonding electron or bonded electron pair when it is bonded to other atom. That is, suppose A and B are bonded with each other, covalent bond, A, B covalent bond. So how many electrons are there in the covalent bond?
Two, sir.
Two.
Minimum.
So there are two electrons in the bond. Now, this electron, if A and B, they try to attract the electron toward themselves. Okay, both. So A is pulling the electron toward itself, B is pulling the electron toward itself.
Yes, sir.
So what happened if the more powerful atom, the more powerful atom will attract the electron toward itself. More powerful. That power is called electronegativity. That power is called electronegativity. If A is more powerful, that means if what happened, electron shifted toward A like this, then A is more powerful. That means A is more electronegative. A is more electronegative. More electronegative. More electronegative. And B is more less electronegative. B is less electronegative or more electropositive.
Yes, sir.
For example, hydrogen chloride or hydrogen fluoride, HF. HF. Now, fluorine is more electronegative. That is why what happened? It gets delta positive and the electron pair shifted toward fluorine. That is why it gets delta negative and it gets delta positive. Delta means the charge is small charge. The magnitude of the charge is very small because the electron pair shifted partially, not completely. That is why it is a partial charge. It is not complete
Yes.
charge, it is a partial charge. Okay. There are many examples, and due to electronegativity, many things happen. The bond gets partial polarity. Dipolar bond. A covalent bond is a non-polar bond, but due to electronegativity, it gets polarity, partial polarity. Okay. Now there are several theory there are several theories for the measurement of so there are several theories to explain the electronegativity and for the measurement of electronegativity. Actually, electronegativity is a qualitative quantity or qualitative property, but different scientists has given different formula for the measurement of electronegativity of the atom. So we will discuss about those formula. First, Pauling scale of electronegativity. Pauling scale of electronegativity. Pauling scale of electronegativity. In this scale, it assumes if there is a reaction, chemical reaction between A2 and B2, A2 plus B2, the product is 2AB.
2 kb.
2AB. Okay. Or we can write like this. A2 is AA, this plus B2, A B plus A, like this.
Sir,
Okay.
A and B are gas molecule.
Maybe gas. Most probably they are gas molecules.
Okay.
For example, okay, chlorine H2 plus Cl2 equal to HCl. Now, the Pauling scale of electronegativity states that given the formula that chi A minus chi B equal to equal to 0.102 0.102 root over EAB EAB minus EAA minus EBB. To the power half. So this is a long formula where that is the electronegativity chi, that is the electronegativity of A atom minus the electronegativity of B atom in mod
Yes, sir.
of only positive value we will take. Okay,
Yes, sir.
mod of chi A minus chi B equal to is a constant. E means energy, bond energy of AB molecule, the bond between A and B. the bond energy of AB minus the bond energy of AA minus the bond energy of BB to the power half. That means
Okay.
the Pauling scale of electronegativity calculate the electronegativity from the bond energy of the molecule. Okay, that is the Pauling scale. Okay, now another scale is there. Mulliken scale. Mulliken scale of electronegativity. Mulliken scale of electronegativity, where the electronegativity is determined from the average of ionization energy and electron affinity. The average of ionization energy and electron affinity of any atom. The electronegativity is calculated. So electronegativity equal to ionization energy of any atom plus electron affinity of the same atom by 2. Electron affinity of the same atom by 2. For example, if we want to calculate the electronegativity of chlorine, then the electronegativity of chlorine KCl equal to the ionization energy of chlorine plus electron affinity of chlorine by 2 by 2.
So we need to find first electron affinity.
Yeah. So in the numerical problem, suppose there is a numerical problem in the question paper, and it is given that the ionization energy and electronegative value will be given. Then you have to calculate the electronegativity from those values, just average of those values.
Okay,
This
sir.
value will be given in the question. You have to just calculate this.
Okay,
Or
sir.
in case of Pauling scale, the bond energy will be given for Pauling scale. Okay.
So is there any formula for finding that bond energy?
Yeah, there are many formula, but that is not required for you. Okay. There is a complicated process is there, and bond energy can be calculated from those experiments, and there is a formula. Born-Haber cycle that is called Born-Haber cycle. So by that cycle, we can calculate the bond energy of any molecule. But that is not required. That is actually included in the chemistry honors syllabus. Or
Okay, sir.
engineering chemistry, that is not required. For you, in the question paper, the values will be supplied. Now, what is the periodic trend of electron affinity and electronegativity? Periodic trend means what is the periodic table status? How it changes in periodic table?
So from left to right,
In the
electron
chlorine,
affinity
from left to
increases.
right, electron affinity increases.
Increases. Yes, sir.
Electron affinity and electronegativity both increases. Okay, both increases. In the group from up to down, electron affinity
Decreases
decreases,
as the size increases.
electronegativity both decreases. That means in the halogen family, fluorine, chlorine, bromine, iodine, acetylene. What is the order of electronegativity? That is the order of electronegativity. Fluorine, in according to Pauling scale, the electronegativity of fluorine is 4. Is 4 value. Pauling scale.
Okay.
Pauling scale value 4. It is 3.5. It is 3.0. It is 2.5. Like this. Okay. Now polarizability. 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 Suppose if there is a big atom like iodine, a bigger atom, so this is the atom and this is the nucleus. This is the nucleus of the atom and there is small atom. There is small atom. They come close to each other. Then what happened? The nucleus of the small atom, the nucleus is positively charged. This is positively charged. This is also positively charged nucleus.
Yes, sir.
Now, this positively charged nucleus will attract the electron of the bigger atom. The electrons of the bigger atom. Because in the bigger atom, the outside electrons are very loose electron or labile
Mostly
electron.
for.
Because the
Yes, sir.
distance between the nucleus and the outermost electron, that is very
Is
large. There
large.
is a large distance between nucleus and these electrons. That is why these electrons are called labile electron. Labile, labile electrons. Labile electron means loosely held electrons. Hmm. Loosely held electrons. So these electrons are easily attracted by any positively charged atom, positively charged ion, or any small atom. If it is a positively charged, then it will attract the electron towards itself, like this. The electron cloud will shift to that atom. The electron cloud shifts to that atom because it attracts the electron cloud.
Okay.
and this phenomena is called polarization. Polarization. So, if there is an ionic bond between uh, lithium iodide, for example, lithium iodide, lithium plus iodide minus. It is an ionic compound, but practically it is not purely ionic compound. It is ionic compound, but not purely ionic compound. It has some covalent character. How? Because lithium is very small atom, lithium plus, this nucleus, lithium plus, and iodine minus. Iodide is very large atom, is negatively charged. So what happens? The electron cloud of the iodine, the ion, the electron cloud of the iodine, it is attracted by the lithium plus, and this will form the electron cloud shift to the lithium plus, and it gradually become like this. The electron cloud gradually shift to the lithium plus, and they form a structure like a covalent like structure, covalent bond like structure. That is why
Sir,
it is not
electron
purely ionic, it is partially covalent character. Partially ionic and partially covalent.
means electron is not shared.
Electron is not shared. So in case of ionic
Means
bond,
transferred, sir. Means totally not transferred.
yeah. In case of ionic bond, one electron transferred from here to here, and they form ion. And there is a Coulombic attraction between the positively charged ion and negatively charged ion. That is ionic bond. In case of covalent bond, electron is shared.
Yes, sir.
But in this type of ionic compound, in this type of ionic compound, because the size is very different, lithium, the cation is very small and the anion is very large. In that
Yes,
case,
sir.
what happens? The ionic bond has some covalent character because the electron is shared with the electron of anion. The electron of anion is shared with the cation. Some sharing occurs. That is why we get some partial covalent character. Clear?
Okay, okay, sir.
So this is called polarizability. Of Polarizability is the property of any atom to form or to get polarized. So where the larger atoms are polarizable. Atoms and ions are polarizable, and smaller atoms and ions, they polarize. So what is polarizable? Polarizable. Which atoms and ions are polarizable? Generally, large atoms,
Very different in size.
large anions are polarizable. Large atoms or anions are polarizable. Hmm. So this phenomenon is called polarizability. The polarization of the large atoms or anions is called polarizability. So what happens? Small um, polarizing ability or polarizing power? Polarizing power and polarizability different. Polarizability for large atom and but there is a small cation, small atom or cations polarize large atoms or anions. That is called polarizing power. Small atoms or cations polarize large atoms or anions. That is called polarizing power. So, in which case the polarizability will be high. Polarizability will be high. High polarizability and low polarizability. We will compare high polarizability and low polarizability. Low polarizability. High polarizability, the conditions for high polarizability is small cation, large anion, here just opposite, large cation, small anion. That is low polarizability. So high polarizability means covalent character. High covalent character. High covalency. High covalency. High covalency. Low polarizability means high electrovalency. High electrovalency. Okay.
Yes, clear.
Clear. What is the time now?
So 340.
Now, another topic I will discuss today, that is oxidation state. Oxidation state. Oxidation state. The number of oxidation state actually the number of electron lost or gained in any atom, that is called oxidation state.
Yes, sir.
or actually the number of electron lost by any atom, that is called oxidation state. That can be positive if the number of electron, if the electron is lost, then the oxidation state is positive. If the electron is gained, then the oxidation state is negative. For example, uh, sodium loses one electron and form sodium plus. So it lost electron. That is why it is plus one oxidation state. So oxidation state
Yes, plus one.
is plus one for sodium. For calcium, it loses two electrons for calcium plus two. Plus, it loses electron. That is why its oxidation state is plus. So its oxidation state is plus two. For aluminium, loses three electrons, and for aluminium plus three, oxidation state is plus three. Right?
Yes, sir.
Now, for chlorine, Cl, it gain one electron. For Cl minus, oxidation state is minus one. Because it gained electron, that is why it is minus. In case of oxygen, it gained two electrons and formed O2 minus oxide. The oxygen state is minus 2. Like this. Now, the oxidation state, uh, you know the oxidation state. Can you find out the oxidation state of K2 chromium? Oxidation state of chromium in this potassium dichloride. What is the oxidation state of chromium in potassium dichloride?
Yes, sir.
Calculate.
Sir, it is 6.
6 plus or minus?
Sir, plus 6.
Plus 6. Okay.
Yes.
Chromium 6 plus 6. Okay. Now, what is the oxidation state of oxygen? What is the oxidation state of oxygen in hydrogen peroxide? H2O2.
Sir, minus 2.
Huh? Minus 2. Minus 2.
Yes, sir.
So, if this is X, okay, what is the oxidation state of hydrogen?
So
What
plus
is the
1.
oxidation state of hydrogen? It is
Uh,
always plus 1. So, there are two hydrogens plus 1 into 2. 1 into 2.
Sir, it will be -1.
Yeah, it is -1. So x into 2 equal to 0, right? Then x equal
Yes, sir.
to -1.
Huh? So there is plus.
Yeah, yeah, plus x equal to -1. Okay. So, can you write some homework?
Yes, sir.
Na2s2o3. What is the oxidation state of sulfur? KaMnO4. KaMnO4. Oxidation state of manganese. H2S2. Uh, H2, no, no, no. Nitric oxide. Oxidation state of nitrogen. Fe2O3. Oxidation state of iron. Fe Fe3O4. Fe3O4. Oxidation state of iron. Okay. And Cu2O. Oxidation state of copper. HCO4. Oxidation state of xenon. Hc2O4. HCO2. Calculate the oxidation state of this molecule. The mass atom of this molecule. So, what is the time now?
Sir.
Time is over. 3:45 or 50,
Yes, sir. Yes, sir. 350.
3:50. Okay. Then today I stop here. In the next class, I will complete this chapter. I will finish this chapter. The rest is the coordination number and geometry of the molecule. Coordination number and geometry of molecule. In the next class, I will discuss about these topics. Then this chapter will be completed.
Okay, sir.
And there is hard soft acid base also is there. Okay, no problem. Do you have
So
any questions,
coordination.
Saurabh? Any doubt?
No, sir.
No
So can
doubt.
you repeat once again the high and low probability? Sorry, polarizability.
Okay, high polarizability. Have you written what I written in the board?
Yes, sir.
You noted down?
Yes, sir. High polarizability, small cation and large anion.
Yeah. So for high polarizability, small cation and large anion. Small cation, large anion. For high polarizability. For low polarizability, large cation, small anion. Because the cation will attract the electron cloud of anion. That is why if it is large, then there will be high polarizability. High, low. So you remember these things?
Sir, then sign will change.
Huh?
Sir, if anion at, attracts from cation, then sign will change, no?
Anion attracts cation.
Sir, electron.
Hmm.
I want to say that if cation attracts electron from anion, then the sign will change or not?
Sign. Okay, this is actually not a permanent phenomena. This is a temporary phenomena. When this cation attracts the electron cloud of the anion, the sign will definitely change because there is a partial covalency. Not, it is not a permanent effect. It is a temporary effect.
Yes, sir.
Okay, that is why we cannot remove the sign. It is a partial character or it is a temporary effect. That is why we cannot remove the sign. Sign is there, no problem. Uh, the electron not completely shifted to the cation, partially some electron shifted to the cation, and it forms a covalent like bonding. But here it is
Yes, sir.
not possible because the anion is very small. Anion is small and cation is large. It is not possible. That is why it is low polarized solution. You just remember these things. Hmm.
Okay, sir.
When there will be when the college will reopen, when you will come to the college, then I will show you something. Um, it can be easy for you to understand these topics face to when we discuss face to face, not in the virtual mode. It is not possible. I show you the models. Okay, in the
Okay,
chemistry
sir.
models, molecular models. If you come to the college after opening of the college, you cannot come now because government has not permitted the students to come to the college. Hmm? That is why
Yes, sir.
after school and colleges opens for the students, then we will meet and discuss about these things, whatever you have doubts. Okay, I will upload the study material in the Google Classroom.
Okay, sir.
You can download from there, or for better understanding, if you want to understand better in better way, you can watch some YouTube video. You can get some YouTube video for polarizability on this topic. They have some pictorial and video demonstration that would be better for understanding.
Okay, sir.
Okay, Saurabh. So let's finish the class today.
So, what are the topics, sir? Sir, you will teach in the next class.
Next class, the topic will be coordination number, geometry of the molecule.
Geometry.
Coordination number and geometry of the molecule.
Okay, sir.
Okay.
Thank you, sir.
Bye, Saurabh.
Bye, sir.